Hello everyone. Today we are going to tell you about the DES, Data Encryption Standard. I am Bhavna Sharma going to start with the presentation which will be later carried out by the Ria Lalwani. DES, Data Encryption Standard. It's a symmetric key block cipher that was published by National Institute of Standards and Technology, NIST. It is an implementation of a Feistel cipher. It uses 16-round Feistel structure and the block size is 64-bit, though the key length is also 64-bit. But DES has an effective key length of 56-bit since 8 of the 64 bits of the key they are not used by the encryption algorithm of the DES. This is an example of a DES block cipher. In this figure, it is an encryption and decryption side of the DES. At the encryption side, DES takes a 64-bit plain text and creates a 64-bit cipher text. At the decryption sides, DES takes a 64-bit cipher text and creates a 64-bit plain text, whereas the same 56-bit cipher key is used for both encryption and decryption. This is a journal DES structure. These are the elements of DES cipher at the encryption side. This encryption process is made up of two permutation boxes, that is, a P boxes, initial permutation and a final permutation, and within it there are 16 Feistel rounds. Each round is using a different 48-bit round key that is generated from the cipher key. As you can see in this figure, 56-bit cipher key is going into the round key generator and it is generating a 48-bit key for each of the Feistel round. Now let's talk about each of the elements of the DES in detail. At first, we'll talk about initial permutations and final permutation P boxes. Each of these permutations takes a 64-bit input, permutes them, arrange them according to a predefined rule. According to predefined rule, just because of the reason, because both of the permutations, they are keyless and they are straight permutations that are inverse of each other. For example, if you see in figure 1, initial permutation, the 58-bit in the input becomes the first bit in the output. Similarly, in the final permutation, the first bit in the input becomes the 58-bit key in the output. So in other words, we can say, if the rounds off between these two permutations don't exist, the 58-bit entering the initial permutation is same as the 58-bit leaving the final permutation. So this is nothing but just in permutations, and we are having a keyless straight permutations, initial and final permutations. As the reason why they are included in DES, it is not clear and has not been revealed by the DES designers. The guess is that it was designed to be implemented Now let's talk about the another element of the DES structure, that is rounds, how the key is generated through rounds. DES uses 16 rounds. Each round of DES is a Feistel cipher. You can say the round takes Li-1, Ri-1 from previous round or from the initial permutation box and creates Ly and Ri that go into the next round or the final permutation box. You can see in this figure above and below. 32 bits Li-1 is present and 32 bits Ri-1 is present in the initial permutation, and the final permutation it is giving L1 and R1 of the same size. We can assume that each round has two cipher elements in between, that mixer and swapper. Swapper is basically obviously an invertible. It swaps the left half of the text with the right half and the vice versa. Whereas the mixer is invertible because of the XOR operation. All non-invertible elements, they are collected inside the function present over here f ri-1, k1. So these are the two cipher elements of each round, and this is at encryption side, a round in DES. This is a DES function. The heart of DES is the DES function, you can say. This function applies a 48-bit key to the rightmost 32 bits to produce a 32-bit output. This function is made up of 4 sections: expansion D box, a whitener that adds a key, a group of S boxes, and a straight D box. These are the 4 sections of the DES. Expansion D box. Expansion D box take the 32-bit input and expand them in more bits 48-bit key as an output. Then it XOR it with a key of 48 bits and give the 48-bit output out of the XOR or the whitener function. S box is a compression box. Is a compression box just because of the reason because 48 bits compressed into 32 bits with the help of S boxes, and they go into the straight D box and come out the 32 bits as an output. This is the normal functioning of the DES function.
Hello, myself Riya Lalwani. I am going to explain about the DES function in detail. Firstly, we will talk about the expansion D box. We need to expand the RI1 to 48 bits. RI1 is divided into the 8 4-bit sections. Each of the 4-bit section is then expanded to the 6 bits. This expansion must follow a predetermined rule. For each section, input bits 1, 2, 3 and 4 are copied to the output bit 2, 3, 4 and 5 respectively. Output bit 1 comes from the bit 4 of the previous section. Output bit 6 comes from the bit 1 of the next section. If the sections 1 and 8 can be considered the adjacent section, then the same rule applies to bit 1 and 32. The number of the output ports is 48, but the value range is only 1 to 32. Some of the inputs go to more than one output. For example, the value of the input bit 5 becomes the value of the output bit 6. And now, the next one is key whitening. Key whitening is a technique which is intended to increase the security of an iterated block cipher. The most common form of the key whitening is XOR, encrypt XOR. Using a simple XOR before the first round and after the last round of encryption. DES uses the XOR operation on the expanded right section and the round key. The round key is used only in this operation. Now, we further move on the S box. S box, substitution box, which is the basic component of the symmetric key algorithms which performs the substitution. S box takes the sum number of input bits m and transforms them into sum number of output bits n, and where n is not necessarily equal to m. An m cross n S box can be implemented as a lookup table with 2 raised to power m words of n bits each. DES uses the 8 S boxes, each with a 6-bit input and 4-bit output, by selecting the row using the outer 2 bits, the first and the last bits, and the column using the inner 4 bits. Now, we move on to S box rule. The 48-bit data from the second operation is divided into the 8 6-bit chunks, and each chunk is fed into a box. The result of each box is a 4-bit chunk. When these are combined, the result is a 32-bit text. The substitution follows a predetermined rule which is based on the 4-row by 16-column table. The combination of the bits 1 and 6 of the input defines one of the 4 rows. The combination of the bits 2 through 5 defines one of the 16 columns. Each S box has its own table. We need 8 tables to define the output of. For example, an input 011011 as outer bits 01 and inner bits 1101. The corresponding output would be 1001, which is highlighted in the table. Now let's go ahead with the key generation. The round key generator creates 16 48-bit keys out of a 56-bit cipher. The cipher key is generally 64-bit key in which 8 extra bits are the parity bits and which are dropped before the actual key generation process. Parity bit drop, which is a compression transposition step before key expansion, which drops the parity bits 8, 16, 24, 32, 60 up to 64. from the 64-bit key and permute rest of the bits. The remaining 56-bit value is the actual cipher key which is used to generate the round key. Shift left. The key is divided into the two 28-bit parts. Each part is shifted left, circular shift 1 or 2 bits. Compression deep box. The compression deep box changes the 58 bits to 48 bits which are used as a key for a. Lastly, we will talk about the DES analysis. First, I will tell you about the avalanche effect, which is a desirable property of the cryptographic algorithms, wherein if an input is changed slightly, the output changes significantly, or you can say a small change in the plain text or key should create a significant large change in the ciphertext, which is good for security. Second one, completeness effect. Completeness effect means each bit of the ciphertext needs to be depend on many bits on the plain text. Diffusion and confusion produced by the D boxes and S boxes in DS shows a very strong completeness effect. Thank you.